We'll now look at the derivatives of the inverse trig functions, and I'm not going to outright derive these, but I will go ahead and just give you all 6 of them. First is sine. The derivative of inverse sine is 1 over the square root of 1 minus x squared. Cosine, inverse cosine has the same derivative just with the sign change, so the derivative of the inverse cosine is negative 1 over the square root of 1 minus x squared. The derivative of inverse secant is 1 over x times the square root of x squared minus 1. And then cosecant inverse is 1 over, or negative 1 over x square root of x squared minus 1. The derivative of inverse tangent is just 1 over 1 plus x squared. The derivative of inverse cotangent is then negative 1 over 1 plus x squared. So while I'm not actually deriving these, it's not impossible to derive using the chain rule, but it is important to note that there's really only 3 different inverse derivatives: inverse sine, inverse secant, and inverse tangent. The other 3, cosine, cosecant, and cotangent, are the same as their cofunction, just with the sign change. So now that we have those, let's actually do some examples of real functions. Here, I want to find the derivative of inverse sine of 4 over x. So, as a side note, we said that the derivative of inverse sine of x is 1 over the square root of 1 minus x squared. Here I don't have inverse sine of x, instead I have inverse sine of 4 over x, so I'm going to have to use the chain rule. So we're still going to have the derivative of inverse sine, 1 over the square root of 1 minus. Instead of x squared, I'm going to have 4 over x squared. And then I need to multiply by the derivative of the inside. The derivative of the inside, it may help to rewrite it as 4x to the negative 1. We would bring the exponent out front and subtract 1. So if we rewrite this, I would have negative 4 over x squared, square root of 1 minus 16 over x squared. Let's do another one. Here I have inverse tangent of the square root of 8x minus 2. If I want to find the derivative of tangent said 1 over 1 plus x squared. In this case, instead of x, I have this huge thing. So the square root of 8x plus 2 squared. And then I need to multiply by the derivative of the inside. A square root is a 1/2 exponent, so we would bring down the 1/2 and subtract 1 from the exponent. But then we also need to multiply by the derivative of what's inside the square root, which is 8. So we're going to have to use the chain rule twice here. If we rewrite this, 1/2 times 8 is 4, over, on the bottom, I'll end up with the square root of 8x plus 2 squared is just going to be 8x plus 2, plus 1 would give me 8x plus 3, sorry, 8x minus 2. So we would have 8x minus 1. And then over here I have the square root of 8x minus 2 from this term. And so there is my derivative.